day 5 of the project, and we finished this entire face, and we've started that face, and we've finished the other face, and today we'll finish all the bracketing for this face here. Project's going very well. All panels are down. You can see that we've got loads of different groups of panels. And again, just looking around, you can't help but notice all the empty panels. Nothing particularly complicated about the job. Each string is terminated, so a group of 15 panels here, and then the end comes out here. We label the end so we know exactly which string it is when we come to energize the system later. So that's principally where we are with the project. It's going very well. Weather's been kind to us, which is good. These guys have been running a generator over there, which has not been ideal, and we can smell the fumes, so hopefully when the panels are on they won't have to run the generator, and that'll help them a lot. Well, hello and good morning to a very sunny and glorious day on the roof today. It's day 7 of the job, and we fitted principally all of the panels. We were missing a few brackets last night, so we're just finishing off the last bit you can see there, but all faces are done. 1, 2, 3 and the balance 4. Today we'll be fitting the cable rails, which are going to be the raceways, where we're going to run all the cables through to the central points here where the inverters are going to be, and we're also going to be fitting the ducting, which is going to bring the 64 cables into the building. I'd say that one of the most challenging or complex parts of any project is how you're going to get the cables from what is a watertight area on the roof down into the building. There are various flashings to the roofs for different types of roofs, but on this kind of roof, better to go on the side of the building. So we'll show you how we do that today. We'll also show you how we run all the trunking cable trays. So I hope you enjoy, and beautiful sunny day here in Park Royal. So Octavian, tell us, what are we up to now?
So we just started doing the first string, yeah. So we're gonna start the first panels that side. We're gonna start all the way up, all across the roof.
Okay, what are you doing? You're doing...
Just installing the first MC4.
Okay.
One of the probably hundreds.
So you've put the first MC4 connector on.
Just the first MC4.
Right, now we're going to run it to there. We're not going to connect it because obviously then the whole rule would be live. But we're going to bag it up. Let's go. Come, follow you. Right, cable ties. Let's go. You can see it's nice and dicey on the roof this morning. What are we up to, Abdul?
Hey, today we're testing this PV string array. By the way we do that, we use the C-Watt PV tester, which will give you the voltage, amperage, and also the insulation resistance of the PV cable that it comes with.
Why are we doing this?
We're doing this to ensure that we're getting exactly what we should be expecting from 15 of these panels. By doing that, we would measure one panel, see how much we get, and we times about however many panels are there in the array. For this instance, we got 15 in here. So if one would be 34 volts, you would times about 15. And this is around the same voltage that you'd be expecting. So doing this to ensure that they're all good before we start wiring them in properly.
Okay. You have yours, eh? I'm taking mine.
So what are we up to here?
So right now what we're doing is we're laying the cables on this cable basket.
All right.
And we've done the cables coming from that string of panels, which is 18 panels and on that side. And here what we're doing is that this is a 30 panels array, and we cut them into 2 strings.
And we're running here, and then we stop in here, and then we're running down. So Octavian's here, and he's got our cable runner. So we're running the cables, clamping them through, and then down. All right, cool. So just a quick update here from the roof. We started to run all the trays and baskets, still day 7. You can start to see all the metal framework being run for all the cables. And we're running them all down these, what we call raceways, bit of a plan there of what's going on, and then running down to here. So these are all the ends of the cables, all spooled up. And then later today, we will start to run them down the side of the building. That's the afternoon. But obviously there's a bit of work involved. There's wonderful teamwork going on here and getting the cable trays all nice. Well, it's toward the end of day 7, and we've finished all the panel fitting. That's 480 panels, and we've done a lot of the strings as well. Final day tomorrow is just to get the cables into the building, generating loads of lovely clean energy from all the panels you can see behind us. Did you have any questions for us about the project?
How many days has it taken?
So it's taken us 7 days to get to this point. So I think total from start to end will be about 9 days. That's including de-energising the bakery downstairs. So we need to take them off electricity for about half an hour to couple the inverter on. So about 9 days, beginning to end, but obviously we've not really interrupted the bakery at all downstairs, which is helpful.
What kind of power are you expecting to
Well, we've got two
bring?
inverters here that are capable of 110 kilowatts each. We're limited because the bakery's only got 200 amp supplies coming in, so we will be at a maximum push of 100 amps from each inverter per phase, obviously, and it's a 3-phase system, so that's kind of the amount of power. So basically we're going to be able to push back as much as they're allowed to push back. If they wanted a bigger supply here, they'd have to contact the DNO and it'd be very complicated and expensive, so we're giving them as much as they can.
And from a cost perspective, what kind of expected to get back from a
So
system like
a
this?
job like this is more than 6 figures, not a million miles from 6 figures, but certainly north of 6 figures, but you can certainly expect payback within 3 to 4 years. It obviously depends a little bit on, you know, some aspects, how the weather is, how the sun is, etc. in that year, but 3 to 4 year payback I think is pretty good going as a return on investment. Well, we're here on the roof. It's the end of day 8 of the job and we're just finishing all the trays. You can see Saeed's hard at work here, zip tying and cleaning the site, which is nice. We've got this big whale of cable over here to show you. This is the cable here, and we're going to be feeding this cable into the building, passing the cables through. It's a beautiful evening. That's the end of our job. So what we're actually doing now is we run all the cable down to the inverter, and now we are labelling all the strings. We've been testing all the strings. We're now going to be putting MC4 connections onto the inverter, and then it will be ready for connection and energising on Monday morning. So that's last step. It's day 9 here today of the project. The weather is absolutely horrific today, so it's a good day to be working inside, as you can see. Not a very nice day to be working outside today. And yeah, here we are. What we're doing outside now is checking the ratios for the CTs.
Okay, L1.
So we're clamping each one.
So right now we are in the patisserie side of the project. So what we have here is obviously our inverter. We also have the consumer unit for the solar, and we have here the EPM, which is designed to control the export management of this inverter. And to that we have tied a grid meter that is monitoring the grid at all times. So that is monitoring the consumption and the production at the same time as the export. And here what we have is a meter for the council to monitor what this site is actually producing at all times, so that it's compliant with the local regulations. To this inverter we have 8 MPPTs, and to those 8 MPPTs we have 240 panels that have been spread out into multiple strings connected to it. It's now live generating 7 kilowatts, as you can see there, and what we have here is our solar consumer board, and obviously we have a fuse for the EPM, a fuse for the grid meter, and the inverter, and the PV meter, and the surge protection device. And this is the main switch to actually turn off completely this generation site. So what you have here is the EPM, which is designed so that in case you lose communication between the inverter and the EPM right away, for example, as I'll show you right now, I will disconnect the data communication between the inverter and the EPM. What you should have here appearing immediately is the generation being cut off. And as you can see there, the generation has been cut off and is now only generating 80 watts. So an alarm will appear, and that happens instantly. As when I put it back in, you will have the EPM in operation, and the inverter will start generating immediately. So that's how the EPM works with the inverter, and this is designed to protect the national grid.
Thanks for the lovely overview. What was the biggest challenge on this job?
One of the most challenging parts is actually getting the right design, and as you see the panels, and you can see a video right now of an overview of the panels, we had to actually set the panels in the correct settings so that it matches the MPPTs correctly, and obviously getting the cable in and making sure that it's watertight 100%. It's been a challenge, and that's the electrical side. And honestly, it's all about the design, and we did a great job at actually designing this project ahead of the time. And so that meant that we had an easy fix on the consumer unit board, and we've had always in mind to put an EPM so that in case anything happens, the system is always protected.
This is just a quick overview of the Solis app. So you can actually see here what is being generated, what's taken from the grid, and what the place is actually using. So it's quite nice. Obviously, it's a very cloudy day today. So. Right, well, we hope you enjoyed the video. That's us done at Ryan Bakery here in North London. They'll be generating hundreds of thousands of kilowatt hours of energy for years to come. And when you're having your pita bread or your sweet kanufa or your baklava, it's going to be delicious and made with green, clean energy from the sun. If you've got a warehouse or building and you're thinking of how you can improve it, put solar on the roof. Solar panels last for 20 years. It's a really, really great way of looking after our planet for the future. Thanks for watching. See you on the next one.